Hello my friends and welcome back to Sky Creative Channel. Today we're diving deep into the fascinating world of tire technology, from cutting-edge retreading techniques to revolutionary manufacturing processes that keep America rolling. Let's get started. Let's start with something truly remarkable. Pete's Tire Barns Inc. has mastered the art of retreading Michelin's revolutionary Tweels airless tires for skid steers. Now, if you've never seen a Tweels up close, you're missing out. This isn't your grandfather's tire. It's an engineering marvel that combines the wheel and tire into one integrated unit, with 30 flexible polyurethane spokes arranged in a specific geometric pattern. What makes Pete's approach so revolutionary? They've cracked the code on retreading what Michelin themselves initially said couldn't be retreaded. The challenge is immense. Traditional retreading involves removing old tread from a flexible tire carcass, but the Tweels integrated design means you're working with a semi-rigid structure where the tire and wheel are molecularly bonded together. Pete's team spent 2 years developing their process, working directly with polymer engineers to understand the thermal and chemical properties of Michelin's proprietary polyurethane compound. They discovered that standard retreading temperatures would literally melt the spoke structure, while standard adhesives wouldn't bond properly to the unique polyurethane surface. The equipment Pete's uses is nothing short of spectacular. They start with custom-modified Marangoni buffing machines equipped with computerized depth control systems. But here's the key innovation. They've added ultrasonic thickness sensors that continuously monitor spoke wall thickness during the buffing process. This prevents accidental damage to the structural spokes while ensuring optimal tread removal. Their buffing wheels are specially formulated with diamond grit in a specific pattern, not the random distribution you'd find on conventional buffing equipment. These wheels operate at precisely 1/200 RPM with a feed rate of 0.003 inches per revolution. Any faster and you generate excessive heat that damages the polyurethane. Any slower, and you don't achieve the surface texture needed for proper bonding. The infrared heating system is equally impressive. Instead of uniform heating like traditional retreading, they use targeted infrared arrays with 47 individual heating elements. Each element can be controlled independently, allowing them to heat just the tread area to 180 degrees Fahrenheit while keeping the spokes at ambient temperature. The temperature differential is maintained using precision thermal sensors accurate to within 2 degrees Fahrenheit. The process begins with what Pete's calls spoke mapping, using laser measurement equipment to record the exact position and condition of each individual spoke. This creates a digital fingerprint that guides the entire retreading process. Any spoke showing stress fractures or dimensional changes gets flagged for special attention or unit rejection. Pre-buffing preparation involves applying a specialized cleaning solution that removes any residual compounds from the original manufacturing process. This solution, developed in partnership with a chemical company in Ohio, penetrates the polyurethane surface to remove microscopic contaminants that could prevent proper adhesion. The buffing process itself is mesmerizing to watch. The Tweels rotates slowly while the buffing wheel makes contact in a carefully choreographed dance. The computer system controls the buffing wheel's position to within 0.001 inches, following the contours of the tread while avoiding the spoke structures entirely. The process generates a specific crosshatch pattern on the buff surface. Not random scratches, but a precisely engineered texture, with peaks and valleys at optimal angles for mechanical bonding. After buffing, each Tweels undergoes what they call geometry verification. Laser measuring equipment checks that the buffing process hasn't altered the critical dimensions. The tread crown radius must remain within 0.010 inches of specification, and the spoke positions can't vary by more than 0.005 inches from their original locations. The new tread application represents the culmination of Pete's innovation. The rubber compound they use is a proprietary blend developed specifically for Tweels applications. It contains 65% natural rubber versus the 45% typical in conventional retreads, but that's just the beginning. The compound includes specialized adhesion promoters that create chemical bonds with the polyurethane surface, not just mechanical adhesion. The tread is applied using a computer-controlled extruder that maintains precise thickness across the entire tread width. The extruder temperature is held at exactly 190 degrees Fahrenheit, hot enough to ensure proper flow characteristics, but cool enough to prevent premature curing. The application speed varies across the tread width, moving slower at the edges where the tread transitions to the spoke areas. What's fascinating is the curing process. Pete's uses custom-built vulcanization chambers that look more like spacecraft than tire equipment. Each chamber maintains 9 different temperature zones across the Tweels profile. The center tread area reaches 285 degrees Fahrenheit for optimal curing, while the spoke transition zones are held at just 220 degrees Fahrenheit to prevent polyurethane degradation. The pressure application is equally sophisticated. Instead of uniform pressure, their system applies variable pressure across the tread surface. Higher pressure in the center where the rubber is thickest, lower pressure at the edges where it transitions to the spoke structure. This ensures uniform density in the cured tread while preventing stress concentration at critical transition points. The quality control process would make NASA proud. Every retreaded Tweel undergoes what Peets calls their 7-stage verification protocol. This includes visual inspection under high-intensity LED lighting, ultrasonic testing for internal voids or delamination, dimensional verification using coordinate measuring machines, hardness testing at 15 different points across the tread, adhesion testing using calibrated pull test equipment, dynamic balance verification, and finally, load testing under simulated operating conditions. The dynamic testing is particularly impressive. Each Tweel is mounted on specialized equipment that simulates actual skid steer operating conditions, forward motion, turning, lifting loads, and even the jarring impacts of construction site operation. The test runs for 45 minutes at loads up to 6,000 pounds per tire, while sensors monitor spoke flex patterns, tread temperature, and any signs of distress. The results are simply outstanding. Peets retreaded Tweels are achieving 85% of new tire life at 60% of the cost. In real numbers, that means a Tweel that originally cost $800 and lasted 200 hours can be retreaded for $300 and deliver another 1,000 hours of service. For a construction company running multiple skid steers, that represents savings of tens of thousands of dollars annually. Now let's shift gears to some serious heavy-duty equipment. The Corgi HD1800 Hydrus isn't just a tire changer. It's a mechanical marvel designed for the biggest tires in commercial service. We're talking tires up to 71 inches wide and 118 inches in diameter. To put that in perspective, that's nearly 10 feet across. This Italian-engineered, American-assembled beast weighs in at 800 pounds and requires a 220 volts 3-phase power supply. When you're dealing with tires that can weigh over 1,000 pounds each, you need equipment built like a tank. The HD1800's hydraulic system operates at 3,000 psi. That's enough pressure to generate 50,000 pounds of force at the mounting head. The machine features a revolutionary hydrostatic drive system that provides infinitely variable speed control from 0.5 to 8 RPM, giving operators precise control when handling these massive tires. What sets this apart is the 4-jaw chuck system, with independent jaw positioning. Each jaw can be positioned independently and locked in place, accommodating wheel diameters from 20 to 63 inches. The system includes laser alignment guides that ensure perfect centering every time, critical when you're dealing with tires this size and weight. Safety is paramount with equipment this powerful. The HD1800 features multiple safety interlocks, including pressure-sensitive floor mats that immediately stop all operations if someone enters the danger zone. The enclosed work area with reinforced barriers protects operators from potential tire explosions. Yes, that's a real concern with tires this large. The efficiency gains are remarkable. What used to take a crew of 4 people half a day can now be accomplished by one skilled operator in under 2 hours. The machine's computer-controlled sequences eliminate guesswork and ensure consistent, professional results every time. For fleet operators running mining equipment or large agricultural machinery, this represents huge savings in both time and labor costs. Welcome to the future of tire manufacturing. Dominion Technologies Group's robotic tire and wheel assembly system represents the cutting edge of automotive automation. This isn't just mechanization, it's intelligent manufacturing that combines artificial intelligence, precision robotics, and advanced sensors to achieve consistency levels that human operators simply cannot match. The system processes up to 240 wheel and tire assemblies per hour. That's one complete unit every 15 seconds. But speed isn't everything. The real magic is in the precision. We're talking about mounting tolerances measured in hundredths of an inch, achieved consistently, hour after hour. At the heart of this system are 6-axis robotic arms equipped with force feedback sensors that can detect variations as small as 2 pounds of pressure. These robots don't just follow programmed motions, they adapt in real time based on sensor feedback. If a tire is slightly stiffer than normal, the system automatically adjusts its approach. The vision system is particularly impressive. High-resolution cameras capture tire bead positioning with sub-millimeter accuracy, while laser profilers map the wheel geometry. This data feeds into the control system, which calculates the optimal mounting sequence for each individual tire and wheel combination. The lubrication system deserves special mention. It applies precisely metered amounts of mounting compound using servo-controlled dispensers. Too little lubricant and you risk bead damage. Too much and you compromise the seal. This system gets it right every time. What really sets this system apart is its integrated quality control. Every assembled wheel undergoes automated testing for bead seating, balance characteristics, and structural integrity. Ultrasonic sensors check for proper bead engagement, while force sensors verify mounting pressure across the entire circumference. This system's adaptability is remarkable. It can handle everything from compact car wheels to light truck assemblies without manual changeovers. The robots automatically select the appropriate tools and adjust their programming based on the wheel specifications scanned from each incoming rim. The impact on manufacturing consistency is dramatic. Traditional manual assembly might achieve 98% first-pass quality rates on a good day. This robotic system consistently delivers 99.7% first-pass success rates while eliminating the ergonomic strain on human workers. It's not about replacing people. It's about elevating manufacturing to a new level of precision and reliability. Here's a process that perfectly blends traditional craftsmanship with modern precision: tire groove removal and replacement. This technique extends tire life in specific applications, particularly in racing and specialized commercial uses, where precise tread patterns are crucial for performance. The process begins with careful analysis of the existing groove pattern. Using precision measurement tools, technicians map the depth, width, and angle of each groove. Modern grooving operations use computer-controlled equipment that can replicate these measurements with incredible accuracy. The groove removal process uses heated cutting tools, essentially precision soldering irons with specially shaped tips that melt and remove rubber in controlled patterns. These tools operate at exactly 850 degrees Fahrenheit, hot enough to cleanly remove rubber without damaging the surrounding tire structure. What's fascinating is the precision involved. The cutting depth is controlled to within 0.5 millimeters. Any deeper, and you compromise the tire's structural integrity. Any shallower, and the new groove won't properly integrate. The process requires steady hands and years of experience to master. Vacuum systems immediately remove the molten rubber, preventing it from re-adhering to the tire surface. Air filtration is crucial here. The process generates fumes that must be properly managed for worker safety. The replacement process is where modern technology really shines. New rubber compound, specially formulated to match the tire's original specifications, is applied using precision dispensing equipment. This isn't just any rubber, it's a complex mixture designed to cure at specific temperatures and bond seamlessly with the existing tire. The vulcanization process uses localized heating elements that bring just the new groove area to curing temperature, around 300 degrees Fahrenheit, while keeping the rest of the tire cool. This prevents damage to the tire's overall structure while ensuring perfect bonding of the new material. This process is particularly valuable in motorsports, where tire grip patterns can be customized for specific track conditions. In commercial applications, it allows fleet operators to restore specific tread patterns that may no longer be available from manufacturers. The cost savings can be substantial. A $500 specialty tire can be restored for $75, extending its service life by thousands of miles. Goodyear's Retread manufacturing training program represents the gold standard in tire industry education. With over 100 years of tire manufacturing expertise, Goodyear has developed a comprehensive training system that transforms novice technicians into certified retreading specialists. The program covers everything from basic rubber chemistry to advanced quality control procedures. What makes it special is the combination of classroom theory and hands-on practice using actual production equipment. Students work with the same machinery they'll use in commercial retreading operations. The training facility features multiple retreading lines, each representing different technological approaches. There's the traditional hot cure system, the newer ambient cure process, and even experimental techniques that may represent the future of retreading. The retreading process begins with comprehensive tire inspection. Every incoming casing undergoes what Goodyear calls the 7-point inspection, checking for structural damage, irregular wear patterns, previous repairs, sidewall condition, bead integrity, overall roundness, and internal condition using specialized equipment. The buffing process removes old tread down to a precisely controlled depth, typically 1/8 inch into the original tread rubber. Goodyear's training emphasizes the critical nature of this step. Too aggressive and you weaken the casing. Too conservative and the new tread won't properly adhere. Repair procedures are covered in detail. Small punctures are filled with specialized rubber plugs. Larger damage requires patches applied from the inside with vulcanizing cement. The training covers when a casing can be saved and when it should be rejected, a critical skill that separates professional operations from amateur attempts. The new tread application process showcases Goodyear's technological leadership. Pre-cured treads are applied using temperature-controlled cement systems. The training covers proper cement application. Too little and the bond fails, too much and it prevents proper curing. The curing process is where science meets art. Goodyear's chambers operate at precise temperature and pressure profiles developed through decades of research. The training covers how to read cure indicators, adjust parameters for different tread compounds, and troubleshoot common problems. Quality control procedures are rigorous. Every retreaded tire undergoes visual inspection, uniformity testing, and selective destructive testing. The training teaches technicians to identify subtle signs of potential problems that could lead to premature failure. The certification process includes written examinations covering rubber chemistry, process parameters, and safety procedures, plus practical demonstrations of core skills. Goodyear certified technicians command premium wages in the industry because of their demonstrated expertise. What's impressive is the program's emphasis on continuous learning. The tire industry constantly evolves and Goodyear's training adapts accordingly. Recent additions include modules on retreading run-flat tires and working with new rubber compounds designed for improved fuel efficiency. The economic impact is significant. Properly retreaded tires can deliver 80 to 90% of new tire mileage at 50 to 60% of the cost. For fleet operators, this training directly translates to substantial cost savings and improved operational efficiency. RMA Tip Top represents German engineering at its finest, precision vulcanizing systems that make permanent tire repairs indistinguishable from original construction. Their one-way repair method transforms tire maintenance from temporary fixes to permanent solutions. The company's vulcanizing materials are specially formulated to achieve molecular bonding with existing tire rubber. This isn't just patching. It's essentially rebuilding the tire structure using materials that match or exceed original specifications. The process begins with careful preparation of the damaged area. RMA's grinding tools create precisely angled bevels that maximize the bonding surface area. The specific angle, typically 45 degrees, is critical for achieving maximum strength in the final repair. Their vulcanizing compounds come in multiple formulations designed for different tire types and operating conditions. Passenger car compounds differ from truck tire materials, which are different again from off-road tire repairs. Each formulation is optimized for the specific stresses and temperatures that tire will encounter. The application process uses specialized heating tools that maintain exact temperatures throughout the cure cycle. RMA's equipment includes digital temperature controllers, accurate to within 5 degrees Fahrenheit, ensuring consistent results regardless of ambient conditions. What sets RMA apart is their materials science. Their rubber compounds include advanced cross-linking agents that create chemical bonds with the tire's original rubber. The result is a repair that's actually stronger than the surrounding material in many cases. The curing process is carefully controlled. Temperature, pressure, and time must all be precisely managed. Their training covers how to read the visual indicators that show when the cure is complete. Undertreated repairs will fail prematurely, while overcured repairs become brittle. The results speak for themselves. RMA repairs regularly outlast the rest of the tire. In commercial applications, these repairs allow expensive tires to return to full service with complete confidence. The process is particularly valuable for specialty tires, where replacement costs can exceed $2,000 per tire. The technique works on everything from passenger cars to mining equipment. Each application requires specific techniques and materials, but the fundamental principles remain the same: precise preparation, proper materials, and controlled curing conditions. It's the kind of methodical, engineering-based approach that turns tire repair from guesswork into precision craftsmanship.